Hi and welcome. I'm trying to learn space science today, the Halley Comet, and after we've done it, we're gonna do lunge training. And if you participate in the lunge training, then it's at your own risk. Now, we read this part here about comets and comet clouds in the previous space science part, but now we're back and we're looking for information about the Halley Comet. And when we're trying to gather these informations together and make a presentation about them. We have come to the final class of objects in the Sun's family, the comets. Perhaps the most famous is Halley's Comet, named after the astronomer who correctly calculated its orbit. Okay, there are comets, and one of them is Halley's Comet, a famous one. It was not discovered, but in a way maybe. Its orbiting was correctly calculated by, I think it's William Halley, around 300 years ago. William Halley examined historical sightings and realized that what had been assumed to be several comets was in fact one object returning every 76 years. Okay, William Halley was looking at historic sightings and and when it was written about it, and then he noticed that it is not every time another one, but the same one returning every 76 years. Comets, William Halley proved, are like planets. They orbit the Sun with strict periodicity. So they are orbiting. Halley is orbiting the Sun every 76 years. Like asteroids, comets are relics of a solar nebula, but their compositions are different. Asteroids formed close to the Sun, so they are stony or metallic, whereas comets were fashioned further out, where ice dominates. Probes have shown comets to be dirty snowballs, loosely packed chunks of ice mixed with grit and riddled with holes. They measure a few hundred meters to a few tens of kilometers across, much smaller than the largest asteroids. Okay, maybe we're going to say something a bit, but asteroids, they have formed mostly closer to the Sun out of more rocks and stones, and metallic and stone, and comets further out, they are more ice and grit loosely packed with holes. Ice and grit and riddled with holes. When far from the Sun, comets are dark and difficult to spot, but because their orbits are highly elliptical, they can approach the Sun closely. So the comets have elliptical rings. So they are far away from the Sun, but then very close, and far away and very close. Slowly the surface ice starts to boil, and shrouding the comet in a giant cloud called a cone. Okay, and when such a comet comes close to the Sun, its ice boils and creates a cloud called coma around the comet. Now two forces come into play. The first is radiation pressure, the push exerted by sunlight itself. So the sunlight itself is doing the radiation pressure. I don't really understand it. The sunlight itself is doing it. The second is the solar wind, subatomic particles blustering outwards from the Sun. These forces push away the coma gases deep into space to form a long, glowing tail downstream of the Sun, the hallmark of a comet. Some tails can stretch for tens of millions of kilometers. Okay, and if such a comet is close to the Sun, the ice of it boils and shrouds it in a cloud. No, called coma. And then the Sun has two forces, radiation. The sunlight itself pushes the cloud out, and also the solar winds. These are subatomic particles. They can also push it through. They are blustering outwards from the Sun. They can push these ice coma cloud tens of millions of kilometers behind and leaving a tail behind them. That's why they're also called shooting stars. Some comets, like Halley, have short orbits circling the Sun every few dozen years. Others take thousands of years, spending much of their life at great distances from the solar system. To astronomers, this suggests that long-period comets hail from a vast spherical reservoir known as the Oort cloud that surrounds the solar system. It is perhaps 100,000 astronomical units across. One astronomical unit is Sun to Earth distance. So 100,000 times as big as the distance from the Sun to the Earth. If it exists, this Oort cloud, as it seems likely, the Oort cloud could be home to trillions of inactive comets. Okay, information about the Halley comet. The Halley comet is a comet, and it's named. It returns in a for comets short orbiting elliptical orbit every 76 years, and was discovered by William Halley in the 18th century, I think. William Halley, and he was looking at the historical sightings, and then he realized that it was not every time different, but it was always the same. And now he predicted it to come back, and now it's named after him, the Halley comet. And comets are a bit different than asteroids. Asteroids are more closer to the Sun. They are more out of metallic and rocks and stones, whereas comets have formed further out of ice and grit, and they are riddled with holes. Ice and grit and riddled with holes. And they're also small. And they have highly elliptical orbits, so they're sometimes far away when they're not easy to spot, but when they're close, when the Sun is boiling the water, it ensures the comet, and if the two forces of the Sun are exerting the forces on them, then that cloud can be pushed for millions of kilometers behind them, leaving it stay behind it with two forces of radiation, that is the Sun itself forcing it, and also the solar winds, and they can push it out. The solar winds, they are subatomic particles bursting outwards from the Sun, subatomic particles blustering outwards from the Sun, with Comet and out, and then but this is what we have to the Halley's comet. I'm going to start the second camera and try this. Halley's comet. Halley's comet is a comet which goes in an elliptical orbit around the Sun every 76 years. It is named after William Halley, who a couple of hundred years ago discovered that it will come back. So he calculated that. He was looking at historical sightings and then found out that it is not every time a different comet, but that it is every time the same one. And so it's named after him because he correctly predicted when it comes the next time, every 76 years. And comets are a bit different than asteroids. Asteroids have formed a bit closer to the Sun, more out of rocks and stones and more metallic are they. And comets have formed further out, more out of ice and grit, and they are riddled with holes. And they're also smaller. And they're going in highly elliptical orbits around the Sun. So not a circle, but an elliptical orbit. And when we're far away from the Sun, we are not good visible, but when they come close, they come pretty close because they're so elliptical around it. So very close technically. The ice in it starts to boil and then shrouds the comet in a cloud known as Comet. And there are two forces now when we're close to the Sun, which are exerting forces on it. There is the Sun itself, radiation, it just pushes the comet with this ice cloud out, and also the solar winds of the Sun, they can push this cloud of ice, this comet, from tens of millions of kilometers out, and that leaves then the tail behind a comet. That's why they're also called shooting stars. And the Halley comet is such a comet. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 27. I'm going to stop the camera. Now, and that was another part to the Halley comet. We're going to come back to comets for another video about the Oort cloud. There's not as much information, but we have what we have in a video also. And then for another video about comets. That means, if you were here for space science, for the Halley comet, then you can go directly to the next part of space science when we're talking about the Oort cloud, and then also another video about comets themselves. Yes, if you stay here and participate in the lunch train, then it's better at your own risk. You're bringing one leg up and you're pointing with the toes down. And the other leg up and point with the toes down. And now, over to one side, the train stop, the toes are pointing forward, stretching the inner side of the leg. And over to the other side. And now momentous, go from side to side. And now lunges. Just go in front, one leg, and down, and back. Move the other leg in front, and back, and front, back, one more. And now to the isometric lunge exercise. First, 90-90 lunge with the legs 90-90, tall up with the back, press from the outside against the knee. Out to the other side and press again. And now again over to that side, now 90, 135-degree lunge, tall up with the back and pull the leg up. And on the other side. And again on the first side, now 90, 150-degree lunge, tall up with the back and pull it the top of the shin bone. And over to the other side. And I think already the last exercise is a rod jumper. Full lunge, tall up with the back and pull it the top of the shin bone again. And over to the other side. And pull it the top of the shin bone, tall up with the back. And now one heel onto the ground, pull the toes in and move the leg from left to right. The garden claw. Our leg onto the ground and move the heel from left to right. And legs wide apart, breathing in, down, down. And breathing in, out. And in. And out. Breathing in, close the legs. And breathing in, out. That was the lunge training. I thank you very much and until next time.